Hi there and welcome back to Triplicate, and today we are going to look at the SG90 servo motor. Now I originally got this ahead of a future project, but while working on the remote controlled lorry, discovered that the steering setup as it is, no matter how much clever software I invent, it's either hard left, hard right or straight on. So it looks like I'm going to have to replace that with a servo motor. So it's time to have a look at it. There we go, comes in unit, comes with the motor, a gearbox, position sensing pots, so you just tell it where you want it to go and it goes there. Comes with 3 different horns that are apparently called, according to the data sheet. As I say, servo motors again are something that are new to me, so shall we see if we can get it going and get it doing something. Okay, so here's the data sheet for it. Which tells you how wonderful it is, and gives you the dimension. Claim the speed in seconds is 0.1. Is that from end to end? Don't know. The torque of 2.5 kilograms at a centimetre, which at 2.5 centimetres is a kilogram, so that's quite a lot of force. That's quite good. I like it. And that's how you drive it. 1 to 2 millisecond duty cycle pulse every 20 milliseconds. And those are the connections, which are ground brown, 5 volts red, and input orange. Well, I reckon that's brown, orange and yellow. However, we won't argue. So we are going to use an Arduino Mega to drive it, because my ordinary Arduino is still somewhere on the remote control lorry and I don't want to detach it. We are going to use this wire that I prepared earlier. So that's, right, you can't see. There we go, brown to brown. Yep to yep, orange, red and yellow as appropriate. So brown is ground, power, ground, the middle one, or red orange, is 5 volts. And I'm going to turn you off because I'm not sure. Oh well, we'll try it. Pin 2. It may be that these pins are only outputting 3.3 volts and it needs 5 volt pulses, in which case I shall have to disconnect the Uno from the remote control lorry. So, right, what I shall do is get some code together just to try and get it to do something and bring you back. Okay, so we have some code. Arduino have a servo library. I just googled the servo, and there's lots of examples on how to do it, so I'm not going to invest a great deal of time in looking at it. So there it is, servo attached. That should be 2 actually, I believe. Gets a bit more light on the subject. Yeah, that's 2. So it attaches pin 2 to it, and then so it attaches pin 2 to the servo, so that's the one it drives. And then I've written, this is in degrees, 0, wait a second, 45, wait a second, go to minus 45, wait a second, go to 90, wait a second, go to minus 90, wait a second, and do the whole lot again. So should we make sure we can see it, plug the old Arduino in, and okay, so select other board, come on, Mega Omega 2560. Okay, we'll try that since that's the board we're using, and we'll fire the code down. Well, there you go, it's doing something. Not quite sure it's doing what I expect it to do. So we will So I'm knocking out the delays to 5 seconds, so it's not jumping about so much. So some commands don't seem to be having any effect. Is that the voltage is too low? So I'm going to turn you off and have a play with it and see why it's not doing quite what I expect it to do. Okay. Problem simple. I discovered the library expects 0 to 180 rather than minus 90 to 90. So I've also put the arm round so it's pointing down the body, and that should be the middle position. So shall we try again? Yep, 45, other 45, all the way around, all the way around, back to the centre. Okay, so we appear to have that working. So now we want to know a number of things about it. How much force is it capable of producing? How fast is it capable of going? Well, we know that because that's going full speed. It's just motoring as fast as it can to its position. And we also need to know, is it capable of going slowly and accurately? So what I shall do is rig up a means of measuring the force. Well, first I shall write some code that runs it through a sequence of fast and slow, and then we shall rig up some means of measuring the force it's producing. And until then, I'll turn you off. Okay, bit of handheld cam, so apologies if it's a bit shaky. Here we go. So I programmed some code into it which runs it through in a sequence, which we will run first up. No load on it. There we go. So full that way, full that way. As you see, it doesn't go all the way to 180. Right, round that way at about the speed it'll go on the steering on the remote controlled truck. And now, just to see how it performs when we ask it to go slowly. There's pretty slow. And here, you see that moving is very slow. It goes 1 degree every half a second. So I think that's okay. Shall we see how it performs under load? And to do that we have a paint tin. We have a piece of wood. We have a big piece of steel to act as a counterweight. That's good. And we have a clamp to hold the motor on, and I shall turn you off to put the motor on because that's a two-handed job. Okay, so we have our servo motor mounted on the end of a bit of wood and held on with a clamp. And now we need a load, for which we have a bolt. Collecting hardware for the next triplicate project. Not really. Why we have a huge great big bolt, I don't know. Somewhere somebody's lorry is probably falling apart. And round that bolt we have a piece of wire which I'm going to put in there, but again that's a two-handed job. And just for the sake of scientific inquiry, I have a pair of scales which are going to tell me the bolt weighs 611 grams. That's a big bolt. Okay, so let's attach the bolt onto the motor and see what we get. Okay, so here we go. Let's see if it can lift 600 and a bit grams. Right, I've got to try and put this wire back in here to get it to turn on. And they're off. Ah, you see. No, it can't get all the way up with all that weight. So, shall we move it into a further in hole and see if it's happier with less load on. Okay, that's a bit further in. We'll measure in a minute exactly how much further in, but for now we'll turn the power back on and we'll see how it's doing. Yeah, it's still not doing quite the whole way. Yeah. Okay, so shall we try it further in yet? I suspect part of the problem is simply the amount of weight that's hanging off the bearings in the motor is just gumming it up. So if we were actually something balanced, it would be better. We'll try it on the innermost hole and see how it does then. Okay, we're on the innermost hole. Shall we see how it performs there? Put the switch back in. Gonna do anything? Yeah. Ah, so that. Yeah, even that's. Okay, well it's probably asking a bit much of it, hanging this enormous great big bolt off the end. And possibly their specifications are a little optimistic. I did work out off the video footage by counting frames. It took about 10 frames to go end to end with no load on it, which is about 300 milliseconds, which is absolutely fine. And this sort of rather brutal test apart, it seems to be quite powerful. So I pronounce myself impressed. It's a good little unit and it only cost a few pounds. So after my minor grumble about the Chinese stuff I bought that hasn't worked, here we've got a success, a score, a good one. I'm impressed by this little servo unit. I shall have to start thinking up projects that use lots of them. So I think I'm going to call that it for this video. Look forward to seeing one of these, well, at least when we're back on the remote controlled truck and in future projects. So on that note, I'll say goodbye, and if you like the channel, please subscribe. If You've got anything to say, leave a comment, perhaps leave a thumbs up, and for now it's goodbye from Triplicate, home of interesting electronics.